Welcome everyone. For today's prep, we're going to look at another rule, which we call the general power rule. So we've looked at and been using quite a bit what we call the power rule. So this is going to be our original power rule that we've considered. So let's just kind of review this. And we kind of view this as a three-step process. So how we actually use this original power rule, think of it as like a three-step process. So we have some function x raised to the power r that we want to differentiate. And how we use this power rule is we take that exponent, we bring it down, put it in front. So that's kind of like our first step. We keep x the same, so we keep our variable the same, and then we subtract 1 in the exponent. What we're going to do is we're going to extend this now to general power functions. So we're not going to be looking at powers of x where it's just x raised to the power r. What we're going to do is now we're going to have stuff inside parentheses. We're going to have a whole bunch of x terms inside parentheses, and that whole thing is going to get raised to the power r. All right, so how do we differentiate something like that? Well, it's going to follow the same kind of steps, except there's going to be one additional step that we do at the end. So step 1, we're going to, and again, when we do this, we have this u of x function, which is inside the power function. All right. So the first step, and maybe let's actually look at some of the examples we're going to do, and then we'll come back to this. So we're going to try a couple of these, and this is just an example of, representative example of what a general power function kind of looks like. So we've got a whole bunch of x terms here. They're inside a big set of parentheses, and then they're all getting raised to this power 4. So we can't just use regular power rule here because it's not, if it was just x to the 4, then yeah, regular power rule. But we have a whole bunch of these terms inside here, and they're all getting raised to this power 4. So we have to use this general power rule. So if we go back, let's kind of investigate how this rule works. So our first step is to calculate the derivative. The first step, just like before, we're going to bring down that old exponent and we're going to put it in front. So our exponent is r. Let's bring it down, put it in front. Then the stuff that was inside the parentheses stays inside the parentheses. So a lot of times we call that stuff inside the parentheses the inner function. And the reason why is, well, it's inside the parentheses. So we're going to call that the inner function. So bring down r, put it in front. We keep the stuff that was inside the parentheses. We keep the inner function exactly the same. That's step 2. Then we're going to subtract 1 from our exponent, just like before. So we subtract 1. And now we have one additional step. And that is we're going to multiply by the derivative of that inner function. So the way to kind of think of this is the first part of this is like our regular power rule, and then we're multiplying by the derivative of the stuff that's inside the parentheses. So it's almost like, and the kind of the way to think of these general power functions, you want to think of them as like a function that has multiple layers. So what we're doing, if we want to differentiate, we have to break our way through the outer layer. And that's what the power rule is doing. It's breaking its way, giving the derivative a way to break on through this power function. So once it breaks through the power function, then we get to the stuff inside, and then we differentiate that. So we kind of differentiate layer by layer here. All right. So let's try an example, see how this works. So the first one we'll look at, the function is, well, f of x. So that means when we calculate the derivative, we'll call the derivative f prime of x. And like we said, there's a whole bunch of x terms inside, and then we have everything getting raised to the power 4. So when we differentiate this, the first thing we have to do, we have to break our way through this exponent raised to the power 4. So that's where the power rule starts. So we're going to bring down the 4. We're going to keep everything inside the parentheses exactly the same. No change. Then we subtract 1 from the exponent, just like before. So we had 4, we subtract 1, we get 3. So this is the power function part. Now, the new part is we're going to take all that stuff that is inside the parentheses and we're going to multiply by its derivative. So for these, it's better not to do it all in one step. I want to kind of tease it out here. So we do the power rule part first, and then we're going to multiply by the derivative of the inner function. And now, let's actually differentiate that inner function. And for this derivative, I'm just using this bracket prime notation. This just means do the derivative of the stuff that's inside the brackets. So if we do that, we end up with 4 times 3x squared plus 5x minus 7 cubed. So this part we're done with. And now we just differentiate the inner stuff. So derivative of the first term, we can just use regular power rule. So we bring down the 2, multiply it with the 3, so we get 6. Keep x the same, and then we subtract 1, so just 6x. And then the derivative of 5x is just 5. And then when we have a constant that's all by itself, the derivative of that is just 0. So we end up with 6x plus 5 here. And really, that's the process. Now, the one thing to be careful of, usually when we do this inner derivative, there's still some terms left here that are being added or subtracted. So you just want to remember the parentheses. So we just want to remember our parentheses. All right, let's try one more of these. So let's look at the square root, the next one, square root of 1 minus x squared. So what we have here, this is a power function, but it's not just square root x. There's a whole bunch of stuff inside the square root. So this is a general power function. It's not just square root x. There's a bunch of stuff inside. So before we do the derivative, though, we can rewrite this, kind of our usual strategy whenever we see a root sign, rewrite it as an exponent, as a power function. So square root gets rewritten as raised to the 1/2. All right, so now we've got stuff inside the parentheses, but then this whole thing is getting raised to the power 1/2. So we're going to do our general power rule. All right, so our function is called y, so we'll call our derivative y prime. And the first step for the derivative process is to kind of differentiate this power function just like regular power rule. So we're going to bring the 1/2 down, put it in front. We're going to keep all the stuff that is inside the parentheses exactly the same. And then we're going to subtract 1 from the exponent. So we go from 1/2, and when we subtract 1, we get negative 1/2. And then, this is the power rule part. So once we're done with that power rule part, then we take all the stuff that was inside the parentheses, the 1 minus x squared, and we're going to multiply by its derivative. So then we finish differentiating. Now, hopefully, this thing that we have left to differentiate, this is a bit easier to do. And this is just a polynomial, so we can just kind of use our regular rules now. So we've got the 1/2 in front. We've got the 1 minus x squared raised to the negative 1/2. So all of this stuff we're done with. And now we just want to differentiate the 1 minus x squared. So the derivative of 1 is 0, just a constant all by itself. And then the derivative of x squared is 2x, and we have a negative in front. So the derivative there is negative 2x. perfectly fine to just leave it like this, but usually a good idea to try and simplify and rewrite it a little bit. So in this case, the 2 and the 1/2 would cancel. And then when we have like these little terms left over here, usually it's helpful just kind of move them in front. So if we were to rewrite this, I might rewrite this as negative x, 1 minus x squared raised to the negative 1/2. All right. So we'll try out a few more of these in class. So we'll see you then. Bye-bye.